And then
We're
Reggie,
good.
I'm going to go ahead and stop sharing my screen. And if you want to load your slides, share your screen.
Great if I started on the right slide, but that's not a bad one to start with.
Great. Well, it looks like we are right at the top of the hour, and so we'll go ahead and get started here. Thanks, everybody, for joining us for the 2021-22 seminar series. If you haven't been a part of the seminars before, the series hosts usually hour-long seminars presented by Fire Lab employees and also other researchers from around the world, covering research topics related to wildland fire. We'll have this same Teams link for all of the seminars this semester, so you can just always use this link. The seminars are usually going to be at this time, which is 11 to 12 Mountain Time, unless otherwise noted. You can see our seminar webpage for more details for the full schedule, and you can get to that from firelab.org. If you go to firelab.org, there's a tab at the top called Seminars, and if you click on that, you can get all the latest information. You can also see previous recordings on that page. I'd also recommend that you sign up for our newsletter if you haven't already, just to get email reminders for upcoming seminars and other seminar series info. I also want to mention we kind of have a special event this semester during the series. We have a two-part panel discussion on the state of science regarding climate and wildland fire. So we'll have a two-part panel discussion on this topic. The first one will be October 28th, and the second will be December 11th. The first panel is going to focus on the state of climate science, including observations, global climate modeling, and regional climate modeling and observations. And then the second panel will focus on the intersection of climate and wildland fire. The panels are going to be 1.5 hours long, so a little bit longer than our normal seminar. And the December 11th panel will be at noon. So it'll be from noon to 1:30 Mountain Time. So that's one change in the timing of the seminars. Okay, so I think we will go ahead and get going here with Reggie. Our first seminar of the series this fall is from Reggie Goolsby. He's a fire application specialist with the Wildland Fire Research Development and Application Program. Reggie has worked in Wildland Fire since about 2010, and he's been a Wildland Fire IT since 2014. He's been tinkering and building software applications since around the early 2010s. Reggie was a developer that brought you Wildfires Near Me, if you're familiar with that new application. He is also a member of the development team for the Interagency Fuels Treatment Decision Support System, or IFTDSS. And he's a solutions architect for the Fire Modeling Services Framework. Reggie says that he loves writing code, designing robust IT solutions, and wildland fire, whether it's sampling fuel plots, dragging a torch, or constructing handline. He says that he loves bridging the gap between fire science and fire management. And so today he's going to talk to us about a new fire modeling services framework. And I think with that, Reggie, I'm going to hand it over to you. It's all yours.
All right. I'm assuming you can hear me. If you can't, someone yell out. Say thank you. So this is today's seminar about the fire modeling services framework. Super excited. We're super excited to finally show people what we've been working on the past few years. So I want to start you with a hypothetical situation. This is why we're here right now, and the reason this is really, really so exciting. What if I told you you can run a model or any computational intensive process from anywhere with unlimited capacity? We could provide you a streamlined process to go from research in the lab to science and users in the field. It was 100% scalable. What I mean by that, you can have an unlimited amount of users at any time. There is guarantee you zero downtime. And in the event we have a Facebook kind of situation that a data center actually goes down, or somebody fat fingers something or does something crazy with the network in AWS, it will automatically fall over to another availability zone, and you will never know about it. What if I told you that technology transfer from the lab to the field, incorporating the 2021 of cloud IT that we could provide that. Well, that's not philosophical anymore. That is real. The Fire Monitoring Services Framework is a model as a service where the models are managed and maintained by us, provided to us by the researchers themselves. We streamline all the data inputs and outputs so they're consistent, that now all the models can get the best information they need to actually not only run, but run efficiently and run fast. We also, working with our partners, who I would not leave out because we couldn't do this without them, provide all the components to actually run those models. That includes your weather data, which is going to be provided by the Fire Environment Mapping System, also known as FEMS, as well as a landscape service, which has been provided to us by Landfire. So I cannot start without saying thank you to those guys. They're our partners, and we really are one big team. Now, while the focus of the Fire Monitoring Services Framework may be on running models, I just want to stress that when we talk about the landscape service and the weather service provided by FEMS, that we're all working together for the common goal there. So what does it actually look like from a 30,000-foot view? So everyone's familiar with WFDSS. We just mentioned IFTDSS, and we also have researchers at the Fire Lab. For those who are not familiar with running models, some applications such as FlamMap, you need a landscape. So we can go to the landscape service provided by Landfire. We can also make edits to those landscapes for those who are familiar with WFDSS and IFTDSS, where you can take a pixel on the ground, modify it to actually what's representative or to actually better be modeled by the behavior. But also we have a location for you to go and get the actual weather input and parameters that you would need for that. We then submit those to the Fire Monitoring Services Framework in a streamlined process. We run those models for you on the latest and greatest cloud architecture, and we return you your results. And the key part about this is you are guaranteed to always have the latest version that's available to the public. No more what I call chasing versions, no more having to make sure you have the latest downloaded version, or just having the right kind of computer to actually run these models. So how do users actually interact with this model, with the Fire Monitoring Services Framework, and what can they actually expect? Well, the human users, as you would think of in the applications of WFDSS and IFTDSS, that use the modeling service, from their point of view, they would never know. When you go to WFDSS and you go to IFTDSS and you run FS Pro or Randig or any of those particular models, all you know is you get the modeling results back faster. They really wouldn't know how or why, which is the entire purpose. All they would do is specify an area of interest, figure out how they want to manipulate their landscape data and weather data, and submit the process. All they're going to notice is improved performance, consistency between the input and output data. So now when you go to WFDSS or you go to IFTDSS or go to another decision support system or any other application, things are actually starting to function and look the same. Less system downtime. Now you don't have to worry about taking your application offline to upgrade models or try to figure out your own deployment process to minimize those downtimes. You get faster results. We're able to utilize the cloud architecture that we have and provide you models on demand. And you have more rapid DME. Now your application developers don't have to worry about trying to incorporate the model. So like, if you don't no longer where you have to have FlamMap in 3 different applications, and now every time there's an update, we have to update in 3 applications. Now it's only one place, and now it's one less thing for your developers, for your applications, for your system that you actually have to worry about. So if you're curious, what are we doing now? Well, IFTDSS is currently connected to a prototype. It's not in production yet. Well, we're aiming to have IFTDSS connected to production in spring of 2022. WFDSS, the next gen WFDSS is under development. They'll be using their services next year in 2022. We have researchers, I don't know if Duncan's on this call or not, but Duncan's been playing with the Fire Monitoring Services Framework. We have others that are actually in there and playing with the prototype we have now. And we're going to enter preview mode in 2022 and hopefully being generally available in the fall of 2022. So that's the background of what is the Fire Monitoring Services Framework. And what I want to talk about now is how we're incorporating this life with fire and what I consider the next generation of IT fire modeling. Can't start with that. You can't understand where you're going to, you know, where you came from. The fire modeling services framework isn't a new concept. The original concept was started around 2012 with the concept of the IFTDSS, Interagency Field Treatment Decision Support System in Joint Fire Science. The idea was they wanted to develop a fire modeling behavior framework. They wanted to develop a service-oriented web application that other applications could use, and they wanted to take the scientific modeling framework and extend it so now you can use it in third parties, and you can make it easier for developers to build models that now could be utilized for downstream systems. They wanted to make it available through a web service. That way, now the transfer of technology and transfer of information has been streamlined. Well, in 2008, the Wildland Fire RDNA and IFTDSS, we have the application, we started looking at this, and it was rebranded to the Fire Modeling Services Framework, not the Scientific Modeling Framework or the Scientific Modeling Playground. And we really wanted to set out the prototype if we could actually build a framework around a RESTful API and incorporate the FLAM-map models, basic and MTT, and, you know, RANDIG and FCONS, and develop a weather and landscape service and be able to edit shapes and LCPs. And we did it inside of IFTDSS. IFTDSS was using it. It was on their servers, and we decided that we would let the government build custom GUIs for testing and proof of concept. It was 2018. We went from 2012 to 2018 saying, let's give this a shot and see what we could do with it. Well, in 2019, we completed implementing RANDIG, Farsight, near term, or FS Pro. We were able to edit landscapes. We had to upload the landscape data from Landfire, but we had all that built inside of IFTDSS, and the proof of concept was there. And we had IFTDSS as the sample GUI, and we had all these architectural diagrams and ERDs and so forth, and things were really, really going well. However, as with most of us know, anytime you start something new, life comes at you fast. So we learned a lot during those 2 years. We learned that we were limited by server capacity. It's one thing to run models. It's another thing to run models that are very computationally intensive. We learned that updating models weren't as streamlined or easy as we thought it could be. It wasn't drag and drop. It wasn't plug and play anymore. We didn't really conform to industry best practice when it comes to security, but that was limited by the environment that we were currently in. We knew that we learned through my own mistakes sometimes. You get a never-ending loop, and a DDoS attack is really easy to occur. So, like, how do we start protecting ourselves from malicious attacks, whether they're intentional or accidental? Hey, I break a lot of things. We also needed better methods of handling landscape data and weather data, and we realized that maybe, just maybe, we were biting off more than we could chew just by ourselves. And we learned that, I don't know if you guys ever tried to write API documentation. It's not only is it not fun, it is very difficult to write it in a way that another developer can take it and run with it. And we also learned that writing API documentation and technical documentation isn't really a skill set that we have really available in the government. So as I repeat, we got started, and then life comes at you fast. Also, the environment was changing. Technology is moving fast. We had Windows versus Linux challenges. We had to make decisions such as, do we embrace a cloud hosting vendor logic, or do we try to stay vendor agnostic? For a very good example, do we just go all in on AWS, or do we go all in on Azure, or do we try to stay as vanilla as possible so it doesn't matter where we are? Honestly, in 2019, 2020, we had to evaluate technologies that just wasn't available in 2018, especially not 2012. Because of this, we realized that we could no longer build for 2019 and 2020, but you had to legitimately plan and build for 2030. That's just how fast the environment is moving. And we also, as we probably all relate, the impacts of aging technology and the increased impact of wildland fire on communities. People need this now. We don't have the capacity to provide it. Things were really not moving in our favor. Think about it. Most people buy a new cell phone or they release one every year. We're releasing software every 5 to 10 years. Well, that exponential growth is true. So get 2 cycles behind and you're 15 years behind where you need to be. We needed to get fire in the hands of the community yesterday, certainly not tomorrow. Today is irrelevant. We need a platform where private, local, state, and federal people could actually use. It does no good to have a service that is limited to 1 or 2 people. Like, we need to, if we can't supply and provide for the world, then have we really hit our target? We need to actually finally serve fire science and research. We have some of the smartest people on the planet, but we don't do a very good job of getting their work into the hands of the people that need it. We need to streamline that process to make their job easier. Our own pace was too slow. I mean, we're the government, that may be true, but that's not an excuse for inefficiency. And we also had external forces at play. Landscape data is updated by Landfire. Where are we going to get weather from? Is this too much for a small team like we had? So, first thing we did is we got out of our box. We reached out to our friends and our partners, and we all came together. Landfire Product Services is one of those relationships and one of those partnerships. Landfire, not just for us, but for the Wildland Fire community, created a REST service that was, now you can get multi-band rasters, or what we used to call LCPs. Let's still call it LCPs. It's a GeoTIFF file now, that of any product that's available in Landfire. You're able to request them. You can resample them. You can get different resolution. You can define your output projection. You can actually edit those in real time now. So, like I've mentioned before, for those who are used to working with this and IFTDSS, Landfire created a landscape service that you can do all of that through a REST API now, available to anyone, anywhere. It's fault tolerant. They went through the same exact testing as the Fire Monitoring Services framework. We actually did it with them. So when we say we have partnerships, it's not, hey, we dropped off a list of requirements. We worked together this hand in hand and became a pretty cool team. Because of this, everything that comes out of the Landfire Landscape Service is 100% compatible with the Fire Monitoring Services framework out of the box. You don't have to modify anything. You get it how you can use it. And now, when you no longer have to update and maintain your Landfire data, you can get it directly from the source and guarantee that you always will have the latest and greatest. It allows landscapes to use what is called raster math and enhanced landscape editing tools. All of that is available. FEMS, the Fire Environment Mapping System, the Climatology API, we worked with the FEMS team, been a fantastic relationship to create. They've created a REST API and a GraphQL API along with some spatial data services where now you can get, well, soon be, this part's not even in preview yet, it's still in prototype, but you can get hourly NFDRS, weather observation, 7-day forecast, and soon to be gridded weather. You can get all this from one source now and be able to get it in a format that is 100% ready for the Fire Monitoring Services framework. You're going to be so some of this data will be behind a credential login. However, a lot of that data will be available through the NIFC open data site or behind the FEMS federated user accounts. Either way, there is a place we work with our partners so that they can provide exactly what you need to run a fire model. And you can always guarantee that now you're going to always have the latest and greatest and the stability. Just like Landfire, they went through the exact same rigor testing that the Fire Monitoring Services framework is going through. We're working with them together. Again, this wasn't, we didn't drop off requirements and go, this is not our job, good luck, give us a finished product. We worked with them. This is truly a team. And again, it makes sure you're compliant with the Fire Monitoring Services framework right outside the box. Just to highlight that, so you have raw point data from WIMS, observation of IRMA, HRR data from GRIDS, forecast data. It's next generation weather for fire. So we've been talking about the past and what we're doing now, but what are we going to be doing in the future? Well, we're open to options. If you think you have something that is relevant for the Fire Monitoring Services framework and you feel like While we have a partnership with Landfire and we have a partnership with FEMS, our next partner needs to be you. Please reach out to us. However, we do have some small requirements. You have to be committed to the Fire Monitoring Services framework way. We do a lot of testing. Things needs to be redundant, reliable. It needs to fit in a cloud-based architecture. And if it is on premise, we still have to go through MaaS server capacity testing. In other words, you're going to know when your server is going to break. That's one thing that, even with the Landfire team, we spent days, if not weeks, doing nothing but overloading servers so they knew their capacity. That comes with, so if you can't provide the hardware, then we can work with you to get some cloud-based solutions. But if you feel like the next partner needs to be you, please reach out. This is a community, and the stronger we are together, the stronger we'll be for the people who are using our products. So forget about yesterday. Today is irrelevant. The future is now. So how do we go from 2018 to 2019 to where we are? Really, it's just old ideas meeting new designs. We kind of transitioned from this idea of a service-oriented architecture to a model as a service. Each model is independent of each other. So instead of saying it's the Fire Model Services framework, I want you to start thinking about, I'm going to run basic. I want that model. I don't want the FMSF. I want that model. So we're providing models as a service. We're able to scale using the AWS SDK. Each time someone requests a model, new resources are allocated independently of other models that could be running at that time. Each model gets its own little mini environment. What that means is no more sharing resources, no more queues, no more, well, we can only run so many at the same time anymore. No, each model is its own little universe. We employ failover capacity through AWS. As I mentioned before, if you have a Facebook situation with some poor person screws up their routing in the data center, we'll fail over to another one, and we'll let them deal with the stress. We're going to keep going. And we have regression testing. We never deploy anything without suitable testing. We're embracing cloud architecture from the get-go. We're fully integrated with Amazon Web Services. We mentioned before, we were trying to decide if we were going to be cloud vendor agnostic. We decided we were going to be cloud vendor dependent. So we are not compatible with other vendors. We're 100% AWS, and we can't leave AWS, so we have to rebuild the Fire Model Services framework. We're fully scalable. There are some AWS imposed limitations. However, those limitations can be lifted. For instance, while I say that we have an infinite capacity, there is a limit of resources they're willing to allocate us, but all we have to do is ask for more. We have those trigger points in place, so that is something that we're always constantly monitoring, that long before we experience any kind of AWS imposed limitations, we would get those raised. Failover safe, like I said, from one availability zone to the next. It's designed to be highly available. We're deployed through CloudFront, which is the AWS Edge network. We have zero downtime deployments. We have an asynchronous modeling API, so you can submit a model. We all know how, for those who don't know timeouts, you can only keep an HTTP connection open for so long. We immediately return you an ID, and you can continuously poll the API to see when it's completed. You can now run models without any impact to your system. So if you're in Worcester, it's PL5. You don't have to wait for your FS Pro in a queue. It will fire off immediately, and it will go, and it won't matter how many other ones they have going. We architected with AWS. We're architected framework in place. And for those who want to learn more about that, you can just Google that, but it really centers around operational excellence, security. We have a great cloud hosting vendor team that we work with. The security officers there have been fantastic. Reliability, performance, efficiency, and cost. I'm cheap. Everyone I work with is cheap, and I hate spending money. So we are efficient. We don't pay for anything we don't use. Like we said before, when we run a model, that once that model is done, those resources are disassociating, given back to AWS, so we're no longer paying for them. That's the entire point. We're not provisioning anything unless we don't need. If there's no models running, there's no servers running with those models on them. So enough talking. So what's available and why should you care? Why do I care? All right, Reg, quit talking. Show me the goods. So what do we have? We have the core models. We have Farsight, Basic, MTT, Randig, FS Pro, and Spatial Fold. Those are what we have available today. Each of those models, as I mentioned before, gets allocated their own resources, and you can run pretty much as many of them as you want within approval process. When you first get an account, you don't have unlimited access like that. But however, everything is available within request. However, just showing you pictures does very little. I want to actually be able to show you what this actually means. So what this means, demo time. This is where things get fun. So I'm going to unshare and now that's my full screen. All right, so now we're back. So on top of the Fire Modeling Services Framework, we have a Swagger interface. Now, all this does is it puts don't want to call it a GUI because I don't want to be misleading, but it puts a way for people to be able to interact with the Fire Modeling Services Framework through something that's a little bit more manageable than your basic curl request. We're going to use this in a minute, but however, I want to bring you over here where I normally work, which is in a code base. So the model that we're getting ready to run is your basic Wildland Fire model. Same one that was mentioned here is in the FMSF suite. These runs are pre-canned. We have created 4 landscapes. Those came exactly from the Landfire landscape service. And just because I can and because it's available, even if this was a PL5, even if there was 100 systems using this, I could do this without any detrimental impact to anybody else. So the idea is not so necessarily to be able to read what's happening on the right, but understand that we just submitted 10 basic requests at the exact same time. As you can see, some of these that are loading it's in a queue. And once they're done, you get a success. And what this does is, while it's running, it's constantly polling the service for each individual run. When it's done, the script downloads it, and you have your basic output. There is no limit to this. If I wanted to fire off 100 at the same time, I could. For those who teach S495, have been through that class. You remember how we used to have to like stagger requests? Now everyone's sending it right now. We get everyone into groups. Those days are gone. Everyone can run their own models at that same time with zero impact to anybody else or the system. It is designed that way. So while these models continue to run simultaneously, independent of each other, they're going to all finish at different times. They're using different size landscapes, all 4 of those. So it's kind of the luck of the draw which landscape that it actually gets. However, they're all done now. So we just ran 10 basic landscapes, and each one of those landscapes are over 200,000 acres. However, you don't have to, if you're going to be interacting with the Fire Modeling Services Framework, most often you're going to be doing it through code. It'll be your developers. However, if you are a glutton for punishment, or if you're looking for, I just want to play with it, we also have the Swagger interface. And so with the Swagger interface, you can Google Swagger if you would like. It's made by Smart Bear. It's a little bit more friendly. I stress that this is not a GUI. This is not intended to be how you use the Fire Modeling Services Framework. But however, it is a place to learn, test, and figure out exactly how you would utilize that in a service. So I'm going to go pull a basic input file. Get the ones we just ran. We're going to do some gridded winds and Scott and Reinhardt. We're going to use landscape ID, which one? 964. That sounds cool. We already got that one. We don't need an ignition latitude and longitude. We're not running FS Pro. And now we can execute that. Of course, it returns a JSON. This is like, I keep stressing, this is a model as a service. I just made a basic input request for this model using the same input files as you would in FlamMap. It returns an ID. I take that ID. And now you know why I do this through code, because this would take a really long time if you had to do all these pieces, right? So of course you see my username. So status mesh. So that was done already. The one I just requested, tell you projection, all the details that you submitted in the input file. And the cool part is now I can go 3508 down here and download it. Here is our model. Go to my desktop. Everyone else's desktops look better than mine. I'm not going to show it to you because it's really cluttered. Guess I will show it to you, even though it's cluttered. There go our outputs. That is it. So we even get the gridded winds coming. Do I think I got output? So these will be the same. Look, Google Earth really fast for you. Bring it onto screen. So actually see where this model was run. Look at your grids now. We ran that with gridded winds. This just came in directly from the modeling service. If you want to run 100 of these at the same time, you could. If you want to run 1,000 at the same time, you could. That's the benefit of the modeling service, is being able to do this now. And you can do that currently with any of these models. And of course, I don't have that much time, so I'm not going to sit here and go through all of these. But if you're curious, you can zoom in. You got basic, Farsight, FS Pro, MCT, RANDIG, spatial flow from consumption, and spatial flow from mortality. So that's the fire modeling services framework in a nutshell. So you just saw that, and now you're wondering, what is the future? So what do we have to do next? We still working on an FMSF SDK. We need a better way of bringing models into the fire modeling services framework. Different people use different languages. Different people use different frameworks. We need a way to standardize how you build models or incorporate models into the fire modeling services framework. We're working on what we're going to call a community version of the fire modeling services framework. It's really a scaffolding project. For any of the developers out there, it's very similar to, if you're Maven, it's like an archetype. Or if you're using Node.js or Vue.js or any of those, it's a scaffolding project where basically you can run a command that will mirror the online version. Of course, no cloud, you're not going to spend new servers, but using different mechanisms, you can actually run a local version of the fire model service framework that would mirror what the behavior that you would get online. That way, to actually aid in model development. We want to get to a point where the first thought when people create a new tool for the field is, I know exactly where this is going. Let's go ahead and build this to get into the fire model services framework so it's available to everyone else. We're bringing on additional fire models. I'm not going to tease you on that one, so that I'm going to keep that one to my chest. I'm going to keep that one secret. You're going to have to wait and see about that one. And we're looking for custom data uploads. Also, I'm not telling you where that's coming from either. You have to stay tuned. I can't give it to you all at once. And we're also, as I mentioned before, we're looking for new partnerships with other entities. We feel that this is the future of wildland fire modeling, and we're not stopping now. If you're interested about any of that, figuring out how to get accounts, maybe forging a new partnership, or figuring out how we could work better together, reach out to either myself, Nicole Valiant, or Henry Bastion. Henry Bastion is our PE, PM. Nicole and I are the co-leads on this project, and she knows more about models than I do. So she's probably the best one when you start talking about models. We have a good relationship. She's the modeling guru. I'm the cloud guru. So it's a perfect team. And Henry, he puts up with us both. So thank you for that. So that's the end of my presentation. I would love to sit down and answer any questions or show any more demos, or pretty much be of service.
Awesome. Thanks, Reggie. So yeah, we'll just go ahead and open it up for questions. People can either unmute yourself and just ask a question. You can raise your hand if you want to do it that way. Or you can type messages into the chat box. So we'll give it a second or two here and see if we get some questions coming in. Reggie, while we're waiting for, oh, I see one hand. It looks like, yeah, Rick Stratton. You can go ahead, Rick.
Hey, Reggie, that was awesome. That's fantastic. All the hard work you guys have done. And you know, I don't know if we can even answer this, but there is a tremendous amount of work going on now in the private sector with fire models, and you know, I don't think they'll be able to leverage this. Is that correct? And you know, and I don't even know if we want them to, but I just see more and more of the private sector doing risk assessments and fire modeling, and what we're doing, and I just don't know where that leads.
Yeah,
I want your thoughts.
All right, I like that one. Come out firing hard. No, that's a very, very good point. That is a topic of discussion that we have discussed a lot. We do feel that it's our duty to serve the community, not just the federal. We currently does not have a mechanism in place for allowing state and private to access the fire modeling services framework, but know that that conversation is occurring. If we could figure out the appropriate security protocols to put in place to actually make our, to make our ISOs not pull their hair out, and also satisfy the goal, that I think it's a match made in heaven. I think that the more we can leverage this system, it's only going to make everyone stronger. For me, this is not about making WFDSS and IFTDSS stronger. It's about making the Wildland Fire community stronger.
Thanks, Reggie. I see there's a question in the chat from Henry. He's asking, how has coordination worked with, say, for instance, Duncan Lutz for spatial FOFOM onboarding?
Coordination has been very, very well. Duncan has been working with us for well over the past year now. He has a developer. So the coordination has been well. Duncan's been joining our meetings. We probably have taken up more of his admin time than I would have liked, to be totally honest. He probably would like a lot less meetings as well. But it's been well. We are actually working on streamlining that process so we don't have to have people sitting in meetings all the time to get the work done, because the more you meet, the less work you can do, right? So up until now, it's been fantastic. He's been very forgiving with the time commitments that we've asked of him. And in return, we've been able to get the 2 spatial FOFOM models into the fire modeling services framework. And if we could leverage that to continue streamlining that process to make it more efficient, I think that moving forward, sorry, Duncan, you're the guinea pig, to say, we will be using a lot less people's time. That way they can do more work. And we all can agree, the more time they have to do work, the better models we're going to get in the end. So up until that, it's been pretty great.
I see there's another question in the chat from Chris and Allison asking, are you looking to integrate, say, the NASA group in San Jose State or Janice Cohen's coffee model or any other models we may have access to?
I will answer about that with, I have a friend of mine, Nancy. So yes, but I say that with the squinting eye. We do have some models that we have targeted. I'm not at liberty to say which ones that we're looking at. It's kind of like the acceptance speech. You don't want to leave anybody out. So just so you are aware, everyone is, if people are willing to be partners with us, we're willing to be partners with them. So the answer is yes, but I can't tell you which ones yet. We're still working on those relationships and partnerships.
Cool. All right, we still have time for some other questions. If somebody else wants to raise your hand or just unmute yourself and ask a question, or I'm still watching the chat box. While we're waiting for just another second, Reggie, can you maybe explain the timeline to me one more time? What's so is the fire modeling services framework available for use now, or what's the status of that? And who, I guess you said like the next gen WFDSS that's under development, that will be a user of this service. Is that the plan?
Yes. So right now, the fire modeling service framework, we're still working on getting towards production. As we all know, connecting to test systems is pretty frowned upon. So right now, no one is using it except for our internal testing team. IFTDSS is using the prototype, but that's only in their test environment. If this production is still using the service that was built back in 2018. It's going to be in preview this spring, in production in preview, which means limited access this spring. That limited access would be WFDSS and IFTDSS, with the goal of going generally available this fall. And then when Rick asked about how can local, state, and private get access to it, that's that general availability part that we are starting to work through in making sure that we figure out the right way to do that. So preview this spring, and by preview, limited access, and that'll be IFTDSS and WFDSS, next gen WFDSS. And this fall, hoping to go to general, which will opening up to a wider audience. Fall of 2022, not now.
Cool, thanks. All right, well, I don't see any other questions in the chat, so maybe we're going to go ahead and wrap it up here. Thanks, Reggie, for your time and for telling us about the fire modeling services framework. Let's see, I just have a couple of quick announcements here. Let's see if I can share my screen for 1 second. Yeah, so next week we'll have a seminar next Thursday, October 14th at the same time, same place. It'll be Joe O'Brien from the Southern Research Station talking about the Athens Prescribed Fire Technology Hub, an integrated approach to informing prescribed fire management. And then you can find the full schedule online here at this link, and you can always send us seminar ideas. You can send them to me at this email address. And we do have a full lineup for this fall, but we can, we're accepting suggestions for next spring when we start back in January. So, all right. Thanks, everybody. Thanks again, Reggie. We'll see everyone back here next week.
Thank you, guys.